So now we're going to set up what is called classification matrix or confusion matrix or classification confusion matrix. Put everything together. Now what this is going to do is it's going to look at the data that we already have here, right? So what we need are these two columns. Okay. What is the actual class of each observation? Okay. And then what is the propensity that we have calculated based on all the predictor variables using some model? Okay. So we haven't started talking about models yet, which we will start from next week, I think. Okay. So there are a bunch of models. You can compare all of those different models by computing the propensity from each of those models and then do some analysis like this. So let's for the moment assume that actually we got these propensities last time we ran a logistic regression, and that's how we got these propensities. So these propensities come from logistic regression model. All right. So these are the only two columns that we need for us to be able to populate this table. So here we're going to specify. Is that coming from outside? Yeah. Oh, okay. Okay. Yeah, somebody. All right. So a cutoff point. Okay. So we specify cutoff point, and usually the default cutoff point is 0.5. If it's like the rounding thing. Okay. So if it is 0.5 or more, you round to the round up, otherwise you round down, right? So that's what we are doing here. If it is 0.5 or more, then you round up to 1, which means it is an event. Otherwise you round down to 0, so it will be a non-event. Okay. So that's your default, but you can, depending upon what errors, the type 1 error is more expensive or type 2 error is more expensive, you can change this threshold value to whatever that you want, which is what we're going to do now. When we change this threshold propensity, now how will the model work? So that's what we're going to be doing. But first we have to set up the confusion matrix that will automatically recalculate as we change the propensity. Okay, so we have to set it up with Excel formulas. So now these are the marginal values are relatively easy to set up. So we will do that. Say you use count if the column is a numerical column. If the column contains non-numeric data, then you have to use count A. A stands for alphanumeric. Okay. So when you have text data, then you use count A to count how many observations there are. So say I'm going to use count. All right. So any one of the variables is okay. So that's the total number of cases, 24. Okay. So here the actual classes are these two, owner and non-owner, and predicted classes are here. So you need to be careful. Sometimes some software packages will have the predicted in rows and the actual in columns. So you have to, be careful. You have to make sure that what is what. You understand that. Okay, whether it is your actual in rows or actual in columns, you have to pay attention to that. But in this case, actual is in rows. So now we want to count. Okay, so we want to count how many events there are. Okay, so here we are defining event as ownership. Okay, owns a riding lawnmower. So here we are not counting simply how many there are, but we want to count only if the content is owner. If it is non-owner, we want to skip over that. right? So we have what is called count if function for that. So then you provide the range. Okay, the range is the whole thing, all right, and then the condition. Okay, the condition is owner. All right. So now this is going to go through that range and pick out all the owners and then give a count of that. Okay. So there are 12 of those, and we can do the same thing for, well, yeah. Here what we need to do is to see how many cases will be predicted as owner. Okay. And how many will be predicted as owner is going to come from propensity. Okay. Two things, propensity and the threshold value, right? So if the propensity is greater than or equal to this threshold value, then you count that as predicted as owner, right? So again, it is a count if, but this works a little slightly in a different way. Okay, so the range is good, there is no problem. Use the propensity column, so that's good. The condition, okay, we have to say greater than or equal to 0.5, okay, and that works in this fashion. Okay. This is the syntax for it, okay, and that is, okay, you have to say, you have to put this within quotation mark, okay, greater than or equal to, all right, and then you have to have an ampersand and the cell address. Okay, and close. So now this will go through that range N12 to N35, and cell by cell it will make a comparison. Okay, that comparison, is it greater than or equal to the value here in E32? If so, then that will get counted. Okay, so anything greater than or equal to the cell content of this is going to be counted as an event, in this case owner, because that's predicted owner. All right. Okay, now one more value and then we will be able to fill out the rest of them here. Okay, and you can do this in any one of these cells, but I'm going to do it in this cell. So here we are talking about the actual class being owner, right, and how many of them are getting predicted as owner. So there are two conditions now. Okay, one condition is it an actual owner, and then corresponding to that is the propensity greater than or equal to the threshold value, in which case it will get predicted as owner. Okay. So, and the function for that is count ifs. Okay. Count ifs gives you an opportunity to build as many conditions as you like. Okay. So each condition will be a range and then a criterion. Range, comma, criterion. Then next one, range, comma, criterion. Range, comma, criterion, and so on. Okay. So first let's do the actual event. So that is the range. Okay. So that's our range to be checked, and owner. Okay. So is that an owner? So that's your first condition, comma, and then the next condition is that column. I mean, the range is that for the range for the second condition is this column, and the condition itself is what we just did, and that would be quotation mark greater than or equal to close quotation and ampersand that and close bracket. Is this good? Okay. So now the rest of the values can be easily calculated from the marginal values. So this is going to be that minus that, right? And that will be that minus that. So this will be that minus that. Then that minus that. And then that minus that. Okay. So now we have a confusion matrix for the given problem. Okay. So now we can go and change this value. So suppose if you change this to say 0.4, then automatically the confusion matrix will be recalibrated for the new threshold value. Okay, because we set it up as formulas. Okay. It is important that you have to set this up as formulas, otherwise the analysis will not work. Okay, and then you know, on the other hand, if you want to make it 2.9, so this is how to turn out. So I put it back to 0.5.